Hi all, welcome back. So today we are going to solve all the questions from Ellipse which came in different shifts of April 2025 attempt. In Ellipse we have total 10 questions out of which 4 are easily doable and 6 are moderate which we are going to solve. This difficulty level is basis my perception which may be different for others. Before we start, here we have summary of each and every question with difficulty level. Hope this will be helpful for you. Here is our first question. Our question says if S and S dash are the foci of the ellipse and P be a point on the ellipse, then min of SP into S dash P plus max of SP into S dash P is equal to. So here in this question, first let's plot the graph. Here we have ellipse. This is x-axis, this is y-axis, and let's say this is S dash, this is S. This point is P. Now we can write this point as a comma 0, which is 0, 2, comma 0, and we can write this point as 0, comma b, which is 0. Now we can also say P as 3 root 2 cos theta, comma 3 sine theta. Now we know that sum of sum sum of focal distances from a point in an ellipse is equal to 2 times a is 3 root 2, 2 times a is 6. But the question asks us about min plus max of the products of focal distances. For that, let's first find eccentricity. This is equal to e square is equal to 18 minus 9.18. From here, we will get e is equal to 9 upon 8, under root of 9 upon 18, 1 upon 2. E is equal to 1 upon root 2. Now we have two options. First option, find focuses and then the product of focal distance. Second option is find it from a directrix. I think the option with directrix is less calculation. So let's go with directrix. X is equal to A upon E. A is 3 root 2, E is 1 upon root 2. So this is equal to 6. And let's say here also we have directrix. X is equal to minus 6. Here is our another directrix. Now S P will be E times P N. First let's write S P into S dash P. This is equal to SP is E times E into P M into S dash P will be E into P M dash E into P M dash. Now we have E square is 1 upon 2. PM is 3 root 2 cos theta minus 6. And PM dash is 3 root 2 root 2 cos theta plus 6. 3 root 2 cos theta plus 6. Now SP into S. Let's say first let's write product of these two modes. This will be 18 cos square theta minus 36. Now let's say our A is equal to this product. So from here we will get our A max will be equal to A max will be equal to, when our cos square theta is equal to 0, mod of minus 36. 36 upon 2 in this is when cos square theta is equal to 0 and A min is equal to, when cos square theta is equal to 1, 18 minus 36 minus 18. Mod of minus 18 is 18 and 18 upon 9. When cos square theta is equal to 1. So from here A max plus A min is equal to 18 plus 9, 27. From here, our answer is option D. Please wait a minute. Option D. And here is our solution, and we can see that our answer is correct. Here is our next question. This question says, if the length of hyperaxis of an ellipse is equal to 1/4 of the distance between the foci, then the eccentricity of the ellipse is. So here length of minor axis. Please wait a minute. So here in this question, our length of minor axis is 2b, and this is equal to 2b is equal to 1/4 of 2ae. 2ae. So 2 and 2 will get cancelled. From here, our p upon a is equal to e upon 4. Now, our e square is equal to 1 minus p square upon a square. Our e square is equal to 1 minus e square upon 16. Multiplying by 16 both sides, taking e square to the left hand side. 17 square is equal to 16. From here, e is equal to 4 upon root 17. So our answer will be option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says a line passing through the point P intersects the ellipse at A and B such that P into PB is maximum. Then we have to find the value for this expression. So first let's plot the graph. This time we don't need to plot axis. Let's plot ellipse. Here we have A, B. Now when we will put root 5 comma root 5 in this, taking one to the left hand side in the expression, we will get less than 0, so P is inside ellipse. Now we can say any point on AB as root 5 plus r cos theta, comma, root 5 plus r sin theta. And also, when we will put this point into the ellipse, our mod of r will be PA or PB. Solutions for mod of r. Now let's put this point in the ellipse. We will get 25 root 5 plus r cos theta square plus 36 root 5 plus r sin theta square is equal to 25 into 36, 900. And now in this expression we will take the terms which have r square inside. We get 25 cos square theta plus 36 sin square theta. Now we will take terms common which have 2 root 5 r. So plus 2 root 5 r, 25 cos theta plus 36 sin theta. 25 times 5 plus 36 times 5, 61 times 5, 305 minus 900, 5, 5 is equal to 0. So from here our mod of product of roots is equal to PA into PB. This is equal to, we can, product of roots is C upon A. You can ignore minus because we have mod 595, and this part will be always positive. 25 cos square theta plus 36 sin square theta. Now here let's replace cos square theta with 1 minus sin square theta. We get 595 upon 25 plus 36 minus 25, 11 sin square theta. So now the question says our PA to PB is max. If PA into PB is max, this means that the denominator of this fraction should be as less as possible. This is when sin square theta is equal to 0. If sin square theta is equal to 0, this means theta is equal to 0. We can say that AB is parallel to x axis. From here our AB will be simply y is equal to root 5. Putting y is equal to root 5 in the ellipse, we will get x square upon 36 plus 5 upon 2. 5 is equal to 1. 5 will cancel 25 as 5. 36 into 4 upon 5. So from here x is equal to 12 upon 5. x is equal to 12 upon root 5. So question asks us about a square plus b square. This will be equal to, this is plus minus, right? Plus minus. So pa square plus pb square will be equal to 12 root 5 plus 5 whole square plus 12 upon root 5 minus 5 square. From here we will take terms common with square. 2 times this into this will get cancelled with minus 2 times this into this. So we get 2 times 144 upon 5 plus 5. 144 plus 25, 169. 169 into 2, it's 338 upon 5. So from here, our 5 times pa square plus pb square is equal to 338. So from here, our answer is option D. And here is our solutions, and we can see that our answer is correct. Here is our next question. This time our question says, let C be the circle of minimum area enclosing the ellipse E with eccentricity half and by this. Let PQR be a variable triangle whose vertex P is on the circle C and the side QR of length 2a is parallel to major axis of E and contains the point of intersection of E, side QR, with the negative y-axis. Then the maximum area of triangle PQR is. So first let's plot our graph. And this is our ellipse. And this is our circle of minimum area which contains the enclosing the ellipse. Now the circle with minimum area enclosing the ellipse E will be simply have the same center as ellipse and pass through a comma 0 and minus a comma 0. This is x, this is y. And this point, let's say, is a comma 0. Now our side QR of length 2a. So this is side QR with length 2a. This point is 0 comma minus b. QR. And let's say our point P is here. Now, center of the circle is same as ellipse 0 comma 0, and here it passes through a comma 0. So we can say equation of ellipse is x square plus y square is equal to a square. From there we can write P as A cos theta, A sin theta. Now, now here, now let's find A and B. Foci is, here we are given foci. So from there A is equal to 2. Eccentricity is half A into half equal to 2. From here we will get A is equal to 4 and A is equal to 4, and now we are going to use formula for eccentricity. A square is equal to A square minus B square. A square is 4, A square is 16 minus B square. From here B is equal to root 3. Now our area of triangle PQR is equal to, this is R, area of triangle PQR is equal to 1 upon 2, 1 upon 2 base, length of base is 2A according to the question, into height of the triangle, which is A cos theta plus B, sorry, A sin theta plus B, A sin theta plus B. Now area of triangle R will be max when sin theta is equal to 1, so A into A plus B. When sin theta is equal to 1. So from here this is equal to 4 into 4 plus 2, 3. Taking 2 common from here, you will get 8 2 plus 3. So our answer is option D, and here is our solution, and we can see that our answer is correct. Here is our next question. This time our questions is the length of the lateral sectum of the ellipse whose foci are this and this, and eccentricity is this is. So if the ellipse with foci this and this, we can clearly see that the ellipse is a vertical ellipse because foci are 2, 5 and 2, minus 3. So distance between foci of vertical ellipse is 2BE, which is 5 plus 3, 8. BE is equal to 4, eccentricity 4 upon 5. From here B is equal to 5. And the formula for eccentricity B square is equal to B square minus A square. B square is square 16, B square 25 minus A square. A square is equal to 9. From here A is equal to 3. So our length of lattice rectum is equal to 2 times A square, 2 times 9 upon B5. This is equal to 18 upon 5. From here, our answer will be option B. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says let C be the circle. Let C be the circle E1 and E2. Be two ellipses whose centers lie at the origin and major axis lie on x-axis and y-axis respectively. This means this is horizontal ellipse and this is vertical ellipse. Let the straight line x plus y is equal to 3 test the curves C, E1 and E2 at points P, Q and R respectively. Given that P is the midpoint of the line segment QR and PQ is equal to 2 root 2 upon 3, the value of this expression is equal. First, let's plot the graph. Please return. Now here we have circle C. Center is at 0, 1. Now our E1, let's say E1 is x square upon a square plus y square upon b square is equal to 1, a greater than b, and a2 is x square upon c square plus y square upon b square equal to 1, where b is greater than c. Now our ellipse E1 will look like this. Center of ellipse E1 is origin, and then we have our ellipse E2. Center of E2 is also y-axis, x-axis. Now here we have our tangent. Please read. So here is our tangent. It touches all three curves C, E1 and E2. Let's also write C from here. X square plus y minus 1 square is equal to 4. Now this is x plus y is equal to 3. Now equation of tangent of circle C will be x1 y minus 1 into y minus 1 into y1 minus 1. This will be plus y into y1 minus 1. There we will have y1 minus 1 plus 2 is equal to y1 plus 2. Now compare this equation with x plus y is equal to 3, because these two are same. We will get our x1, y1 p, x1, y1 as 1, 2. Now P is midpoint of the line segment QR. R is for 2 here we have Q, P, Q and R. Now P is midpoint and PQ and PR are same, which is 2 by 3. So let's write parametric equation of x plus y is equal to 3 from point 1 comma 2. X minus 1 upon cos 135 minus 1 upon 2 equal to y minus 2 upon sin 135 degrees is equal to PR or PQ, which is plus minus 2 root 2 by 3. Now from here Q will be with the minus sign. Our Q will be root 2 by 3 5 by 3 comma 5 by 3 comma minus 2 by 3 4 by 3 5 by 3 comma 4 by 3 and our R will be plus sign minus 2 by 3 1 minus 2 by 3 1 by 3 2 plus 2 by 3 8. So from here we have our Q and R, points Q and R and our point P. So our required expression 9 times x1 y1 plus x2 y2 plus x3 y3 is equal to 9 times x1 y1 is 2 plus x2 y2 is 20 by 3 and x3 by 3 is 20 by 9. x3 by 3 is 8 by 9. From here we will get 28 plus 18 and this is equal to 46. From here our answer will be equal to 46 and here is our solution and we can see that our answer is correct. Here is our next question. This time our question says the center of a circle C is at center of the ellipse E. A greater than B, let C pass through the foci F1 and F2 such that circle C and the ellipse E intersect at 4 points. Let P be one of these 4 points. If the area of triangle PF1 F2 is 30 and the length of major axis of E is 17, then the distance between foci of E is. So first simply let's plot a curve please wait a minute. Now here we have ellipse. Here is our ellipse. Here is our ellipse and our circle C has same center as ellipse E. So this means The center is 0, comma 0. Let's draw a circle. So here is our circle. Here is our circle. This is y-axis. This is x-axis. And pass through foci. So this is F1. This is F2. And let's say here is our point P. Now according to property of ellipse, this is a right angle triangle and this is perpendicular. So from here we will get 1 upon 2 Pf1 Pf2 F1 into Pf2 is equal to 30. And length of major axis is 2a, which is also equal to P of F1 plus P of F2 is equal to 70. Now P of F1 plus P of F2 whole square is 17 square is equal to 17 square. From here we will get P F1 square plus P F2 square, and our root will be, let's take root at the same time, 17 into 17, 9, 4, 1, 4, 1, 8, 8, 1, 289, root of 289 minus 2 times PF1 PF1 into PF2 is equal to 60 and 2 times is 120, so minus 120. So from here this is equal to 169, this is equal to 13. So from here our answer is option B. And here is our solution, and we can see that our answer is correct. Here is our next question. This 10-hour question says let for two distinct values of P, the line y is equal to x plus b touch the ellipse E at the points A and B. Let the line y is equal to x intersect E at the points C and D. Then the area of the quadrilateral ABCD is equal. Now here let's first quickly plot. We can make it without axis. So let's add axis. Here is our ellipse. Let's say here is our line. Y is equal to x plus b, and it also touches ellipse here. These are it. Yes. At points A and B, and let's say here is our line. Y is equal to x. This is C and this is E. So here is our quadrant. Now, now, now here our contact of tangent in ellipse will be minus plus a square m minus plus a square m upon under root of a square m square plus b square comma plus minus b square upon under root of a square m square plus b square. And our m is equal to 1 because this is our line, and here our slope is equal to 1. From there we can say our a is minus 16 by 5 comma minus 16 by 5 comma yes, 9 by 5, and b is 16 by 5 comma minus 9 by 5. Now let's put y is equal to x in the ellipse. We are putting to find the values of b and c. We are going to get x square upon 16 plus x square upon 9 is equal to 1. From here we will get x square is equal to 9 into 16 upon 5. So x is equal to plus minus into 12 upon 5. 12 upon 5 is equal to plus minus 12 upon 5. From there, let's say from here, our y will also be equal to plus minus 12 upon 5 because we are finding intersection from y is equal to x. So from there, our b will be, because it's in fourth quadrant, means 12 by 5 minus 12 by 5. C will be 12 by 5, 12 by 5. Now, area of triangle A is area of triangle A C B is equal to half of mod of determinant of minus 16 by 5, 16 by 5 and 12 by 5. And then 9 by 5 minus 9 by 5, 12 by 5, 1, 1, 1, determinant mod. This is equal to 1 upon 2 mod of, let's open the determinant, minus 16 by 5 into minus 21 by 5 minus 9 by 5 into 4 by 5 plus 1 into 16 into 12. 16 into 12 will be 2, 1, 8, 9, 192, and 9 into 12. 9 into 12 will be 8, 1, 0, 8, 0, 1, 0, 1, 300, 300 upon 25. So from here, this is equal to, this is equal to 1 upon 2 mod of 16 into 21. 16 into 21 is 6, 12, 1, 13, 2, 3, 336, 9 into 4, 36. So again 300 by 25, 300. This cancels by 12. So 300 by 25 is 12 plus 12 is equal to 12. From here, our area of A, B, C, D to 2 times 12 to 20. From here, our answer is equal to option B. And here is our solution, and we can see that our answer is correct. Here is our next question. This time, the question says let the length of a later sectum of an ellipse be 10. Its eccentricity is the minimum value of this function. Then a square plus b square is equal. Now later sectum, length of later sectum is 2b square by a is equal to 10. So from here b square is equal to 5a. Now we need to find minimum value of this function. This is clearly upward facing parabola, so we will take derivative. We get 2b plus 1 is equal to 0, t is equal to negative half. And then our e is equal to f of t min. F of t min, t is minus half, we will get half, 1 upon 4 minus half plus 11 upon 12. From here, this is equal to minus 1 upon 4, 8 upon 12, 2 upon 3. E is equal to 2 upon 3. E is equal to 2 upon 3 now our E is E square is equal to a square minus b square upon a square. This is equal to 4 by 9 from here. 4 by 9 is equal to a square, b square is 5a, so minus 5a upon a square. So from here we will get 4a square is equal to 9a square minus 45a, taking 5a common, we will get a minus 9 is equal to 0. So from here our a is equal to 9. A is equal to 9, then b is equal to 3 root 5. So our a square plus b square is equal to 81 plus 45 126. From here our answer is option B. And here is our solution, and we can see that our answer is correct. Here is our next question. Our question says, let the ellipse pass through the center C of the circle, this circle of radius R. Let F1, F2 be the focal distances of the point C on the ellipse. Then we have to find the value of this expression. 6F1, F2 minus R is equal. Now this ellipse pass through, first let's write equation for ellipse. X square upon 4 upon 3 plus y square 4 upon p is equal to 1. Now for C, S, which is center, will be 1 comma 2 and radius will be equal to under root of 1 plus 4 plus 11, which is equal to 4. Now S E passes through S. E passes through S. So from here we will get X square E passes X square, sorry, not X square, 1, so 3 by 4 and 4 plus E is equal to 1. From here we will get P is equal to 1 4, or P is equal to 1 upon 4. Now from here we can clearly say, that E is a vertical ellipse. So now F1 will be B plus E K, and F2 will be B minus K, where passes through the center. Let's change. This is S and this is C. And our C is H comma K. Let's say. So from here our F1 is P. Now here B is 16 plus, sorry, B is 4, root of 16, 4 plus eccentricity. Eccentricity is equal to under root of 1 minus 4 by 3 upon 16. So our E is equal to root of 11 by 12. Under root of 11 by 12 into 2 is 4 minus under root of 11 by 12. So from here our f1 f2 is equal to 16 minus 11 by 3. So from here we get f1 f2 is equal to 37 by 3. 6 times f1 f2 minus r f1 f2 minus r is equal to 6 times 37 upon 3, which is 37. 4 r is 4 is equal to 7. So from here our answer is option C. And here is our solution, and we can see that our answer is. So hope you found this video helpful. Thank you for watching.